Okay, so in this video we're just going to introduce the concept of adding vectors geometrically using the tip-to-tail method. Okay, so just to do a quick recap, we've talked about vectors and scalars in the past, and a scalar is a physical quantity which has only magnitude, whereas a vector is a physical quantity which has both magnitude and direction. And so examples of scalars would include things like time, mass, temperature. Okay, those are physical quantities which have magnitude but not direction. And then our vector quantities are going to be things like displacement, or velocity, or acceleration, or force. All of those are physical quantities which have both magnitude and direction. Now, we have seen in the last unit at least one situation where it's necessary to be able to add vectors. And the concept of adding vectors is a little bit new to us. Of course, you learn how to add numbers, in elementary school, but adding vectors is a completely new concept. In the last unit, we talked about adding vectors in the context of Newton's second law, because Newton's second law says that the net force on an object is equal to its mass times its acceleration. But the net force is the sum of the forces acting on an object. Okay, and so by definition, that involves adding, because sum means add, forces, and forces are vectors. So we've already seen at least one situation in which it is necessary to be able to add vectors. Another situation, this is kind of convoluted, but another situation where you might need to add vectors would be, for example, let's say you leave your house and you go, 10 miles north, and then 5 miles east, and then, 12 miles north of west at 30 degrees, and you go on this journey and you have all these twists and turns. Your ultimate displacement at the end of the day is basically going to be the sum of all of those individual steps that you take. And so in that situation, if you were to take each of those displacement vectors that I just said and add all of them together, it would give you a result that that is basically a vector pointing from your initial position to your final position. And so there's a few different situations where we want to be able to add vectors. And as you would imagine from dealing with vectors in the past units, adding vectors is more complicated than adding numbers. Okay, so you can see in this image right here, we have, this is basically just to show you, if you're adding 10 plus 10, of course the answer is 20. But if you're adding vectors and each vector has a magnitude of 10, then how you add them depends on the direction of each of those vectors. And so this top row, the sum of these two vectors, is not going to be the same as the sum of these two vectors. Even though this is 10 and this is 10 and this is 10 and this is 10, these two answers are not going to be the same, because you can't just look at the magnitudes of the vectors. You also have to take into account direction. And so adding vectors is much more complicated than adding scalars. So the sum of two or more vectors has a special name. When we add two numbers, we call it the sum. Or not two numbers, but when we add two or more numbers, we call it the sum. When we add two or more vectors, we call that the resultant vector. And so if you imagine two vectors, vector A and vector B, if you take vector A plus vector B, the sum of those two vectors is what we call the resultant vector. Okay, now in this video, we're just going to briefly talk about vectors geometrically and how you might add them qualitatively in a geometrical way. We've seen this in the past, but geometrically speaking, a vector can just be represented by an arrow, right? The length of the arrow corresponds to the magnitude of the vector, and then the direction of the arrow, whichever way the arrow is pointing, represents the direction of that vector. Now, a vector is defined by its magnitude and direction, which means that as long as you don't change either the magnitude and direction, you can shift a vector around as long as you don't change either of those two quantities. And when I say that, here's what I mean. Okay, so imagine I have a vector here. This is vector A, and it has some magnitude and it has some direction. You can see up here the magnitude of this vector is 26.9. Units don't matter because this could represent any physical quantity, and the direction here is 42 degrees above this horizontal. Now, if I take that vector if I shift it around, notice that none of the information about the vector up here changes. Okay, I can shift it left, right, whatever, as long as I don't change which way the arrow is pointing, and I don't change the direction of the arrow, I can shift a vector around however I want, without any loss of generality. And now, of course, if I actually change the direction, then you can see that changes lots of different things. Okay, but I can shift, or I guess the mathematical term is translate, a vector around. And as long as I don't change the magnitude and direction, then it doesn't change anything about that vector. Okay, so keep that concept in mind for what we're about to see. Now, most of our time adding vectors is going to be adding using what's called the component method, which is a more quantitative mathematical thing to do. And so before we get into that in the next video, we're just going to look at a very simple, quick, qualitative way for adding vectors geometrically using what's called the tip-to-tail method. Okay, and I have laid out the steps to the tip-to-tail method right here. Okay, so the tip-to-tail method is a way to add vectors geometrically, not in a quantitative way, really. It can be done quantitatively, but we're not going to do it. This is more of a qualitative way to just roughly sketch out, given two vectors, which way would the resultant be pointing. And so here's how the tip-to-tail method works. You draw your first vector. It doesn't really matter where you draw it on the paper because, again, you can translate a vector however you want without changing anything about that vector. Step 2. You take the second vector and you draw it with its tail starting at the tip of the first vector. Now, when I say the tip of the first vector, I mean the arrowhead. The tail of a vector is the side of the vector that does not have an arrowhead. So, here's what that would look like. Let's say this is vector A. Okay, and let's say I want to add vector B using the tip-to-tail method. First, I would draw vector A. I'll just put it out there in the middle. And then I would draw vector B with its tail. I'm going to make vector B look different. I'm going to move vector B so its tail is at the tip of vector A. I'll actually make it a little bit over here just so you can get a good view. Okay, so if you were drawing this on your paper, you would draw A first and then B. Now, because of the way vector math works, A plus B is the same as B plus A. So in reality, it doesn't really matter which vector you draw first, but the tail of the second should be drawn at the tip of the first. So again, notice I've placed vector B so that the tail of vector B is at the tip of vector A. Then, going back to the notes, what it says is draw the resultant vector by drawing a vector from the tail of the first to the tip of the second. That's why this is called the tip-to-tail method. So we are going to draw a vector starting at the tail of vector A and going directly to the tip of vector B. Okay, and so what that would look like if you were to draw that on your paper is you would start at the tail of the first vector and you would draw an arrow going to the tip of the second vector, and it would point that way. Okay, so if this is vector A and this is vector B, the resultant, which I will call R, would be drawn like this. So this black vector right here is the resultant vector. Okay, and luckily the simulation also does the resultant vector for us, so we can kind of put that on there in case you don't trust my sketchy looking arrow. But you can see if I line it up correctly, it looks pretty close. Somehow my handwriting is so bad I can't even draw an arrow given a grid. But the dark blue arrow here represents the resultant of vector A plus vector B. Okay, and so that's basically how you would apply the tip-to-tail method. And again, this is done in situations where you don't really care about calculations or anything quantitative. You really just want to do a quick estimate of which way the resultant is going to be pointing. Okay. Now, if you want, if you're still trying to figure out, like, what does this mean physically? Again, I'll give you an example. Let's say I start right here. I leave my house. I go north by this much, and then I go west by this much. In this case, the resultant would just represent my displacement. Okay? In essence, I'm adding two displacement vectors, a plus b, and the resultant would represent where my ending position is. Or if you think of these as being forces, right? Imagine these vectors represent forces acting on an object. If I were to add them, of course, that resultant would represent the net force on that object. Okay, so in the context of forces, we don't call it the resultant force. We call it the net force. Although you might actually see the term resultant force sometimes on the IB exam. Sometimes they like to use that word resultant, but resultant force and net force mean the same. Okay, and so we have now seen how to use the TiptoTail method to find the resultant vector by adding two vectors geometrically. Just to show you one or two quick examples of that, this is from a vector addition worksheet, which I will share with you guys later on. Let's say I want to add these two vectors qualitatively. I have an arrow going up, and I have an arrow going to the right. What I would do is, making sure to keep the lengths roughly the same, I would draw the first vector. I would take the second vector and draw it with the tail of the second, starting at the tip of the first. Okay, so I would start at the tip of my first vector and draw my second vector. Trying to make sure that the length is roughly correct. And then the resultant would be drawn from the tail of the first to the tip of the second. In other words, if this is vector A and this is vector B, this would be the resultant, which would be A plus B. Okay, so here it's just an arrow going up and to the right, basically. And again, I apologize for my bad handwriting. A lot of the time, if you look at the directions, it says to use a ruler. I'm obviously doing this on my tablet at home, so it's hard for me to draw perfectly straight arrows, so I apologize for that. But hopefully you get the sense for how to use the tip-to-tail method. Okay, you can also see another example up here as well, where they're showing you that this vector plus this vector, if you use the tip-to-tail method, if this is vector A, this is vector B, you can see how they're using the tip-to-tail method to find the resultant R right here. Okay, because they did A, they drew vector B with the tail of vector B at the tip of vector A, and then the resultant is drawn from the tail of the first to the tip of the second, going this way. Okay, please make sure when you're drawing the resultant, by the way, resist the urge to do weird stuff like this. Okay, so I see this a lot of the time. People will do this. They're doing the tip-to-tail method, and they'll do, okay, this is A, this is B, and then they'll just like, I don't even know, like, do this. Okay, first of all, the resultant vector is a vector. It has magnitude and direction, so you can't just draw a line. Secondly, the direction matters. Okay, that's why I went over the steps for the tip-to-tail method. The resultant vector is drawn from the tail of the first to the tip of the second. Okay, so hopefully you have a sense for how to add vectors geometrically using the TiptoTail method. In the next video, we will look at adding vectors using the component method, which is much more labor intensive and much more quantitative and accurate. As always, please let me know if you have any questions, and I'll see you guys in the next video.